Carpentry can be tough in cold winter weather, but it's all part of the trade. When the going gets tough, the tough get going, right? Marshall McLuhan said, "We shape our tools, and our tools shape us." I don't think there's a better example of that truth than with these Journeyman Carpenter Sawhorses. There was a day when a carpenter's resume was something they'd made instead of something they'd carefully contrived with a computer and printed out on heavy paper stock. A carpenter can apply for a job with a highly polished resume, answer a bunch of questions correctly, and go on for hours about everything they have done and everything they can do. But a savvy employer can tell truth from fiction in just a few minutes watching someone work with tools in their hands. And showing up on a job site with well-made sawhorses like this one can be a lot more meaningful and a lot more useful than a 4-page resume. With that in mind, let's head back to the shop where it's warm, and I'll show you how to make a pair of sawhorses like this in a more practical size. But allowing the sawhorses to shape you and to shape the way you work, that's still up to you. Well, I gathered up the materials needed to build a pair of these sawhorses. And first off, I've got 1x4s, 12 feet long. This is D pine. It's nice and clean, makes for a very nice finished product. And it's got very few or no knots at all, depending on where you get it. I got 12 footers because that's the most efficient cutting for the legs and the tray braces on the sawhorses. But you can also get 8 footers or 16 footers as long as you manage what you cut from where, so you don't end up with more scrap than material. Next, I've got a 1x6 D pine, 8 feet long. That's used for the protector cap across the top of the sawhorses. And it takes a 2x6, 8 feet long for the support for the top of the sawhorses. But I didn't like the 2x6s at the lumberyard, so I got a couple nice looking 2x4s, and I'm going to make those into a 2x6 next. I also have the sheet goods needed for the sawhorses. This is 1/2-inch Russian birch plywood that I'll use for the gussets on the ends. You can use 3/4 inch if you have it. And this is 1/4 inch Russian birch. It's the metric equivalent that I have for the tray on the bottom. Russian birch is nice and strong. It's nice to work with. It's a little less weather resistant. So you can use 3/4 inch. You can use exterior grade plywood if your horses are going to be out in the weather more. Also on these horses, I'm going to give them a coat of spar varnish at the end to preserve them, make them nice looking, and so I'm less concerned about the durability of that plywood. I'll cover the fasteners that are needed for assembling the sawhorses later on when they're actually being put together. But for now, I'm going to make a 2x6. If you're able to get a 2x6, you can just skip ahead in the video to the point where I get this done and the actual cutting process starts. And all I'm doing to make this 2x6 is scanning the lumber to pick the 2 best edges that will get glued together to make the 2x6, and marking them so I can joint them and glue them together. And this way, a couple of the knots that are on this edge will get trimmed off. A quick pass over the jointer will remove the rounded edges on the board and make it perfectly flat, straight, smooth, and square, so I get a flawless glue joint when I make this piece. A quick check with the square assures me that the fence is accurate and hasn't got bumped since the last time I used it. A pass of a little less than 1/8 of an inch will clean up the edge nicely. And that'll be perfect when it's glued and clamped. The glue up process is pretty simple. I've marked the board on each face so I know what lines up with what. Slide this horizontally in the vise at a convenient working height and lay down a couple nice flat full beads of glue. This will be plenty. The other half of my triangle lines up down here. And I just give this a quick rub to evenly disperse the glue. I want to make sure the whole surface is covered, and most importantly out at the edges. I've got a little more rubbing to do for this middle part. Give it a little help, but the main thing is I want the whole surface to be 100% covered so there's no dry spots. Once it's wetted with glue, the glue will flow under the clamps. If there's a dry spot, it can get left out. I could use one of those glue roller things. I do that a lot, but this rubbing of the joint works pretty well also. Just snug it down. You can feel it start to pull and tighten up. Make sure the ends are lined up. Start clamping somewhere near the middle. And line up a face as I go. If there's any thickness variation in the pieces, it'll show up on the back side. And because both of these edges get trimmed off, I'm not worried about clamp marks at this stage of the game. It's a good habit to get into alternating clamps from one side of the board to the other, because thinner boards will tend to pull and cup if you're not careful. I'm using leverage at the end of the board down here. Line up these faces as the clamp pressure comes on. And what you're getting here is kind of a bonus in the video, because normally gluing up has got nothing to do with building Journeyman Sawhorses. I've got a nice little bead of glue squeeze out all the way along, which is exactly what I'm looking for. Put in the clamps about every foot. As the glue begins to grab and get squeezed out, it makes that joint stick better. But the good thing is, by clamping it up this way, if I take two pieces that are bowed like this and then bend them straight, when they're being clamped, the end board comes out straighter than either of the individual boards. And that's a good thing. I'm having trouble with the end down here, but that's all right. If the glue grabs and sets, it'll quit being so much trouble and behave just like it needs to. The other end decided to put up a fight too, but that's all right. I'll just keep fighting because I know I'm going to win. A bucket of sawdust and a sharp putty knife cleans up the glue squeeze out in no time. And with an hour or so in the clamps, that'll be good to go. After allowing sufficient time in the clamps for the glue to dry, I just remove them and straighten an edge on the joiner, and then rip this piece down to 5 9/16 inches and run it over the joiner again, so that I end up with a piece that's 8 feet long by exactly 5.5 inches wide. And that's what you'll have when you come back from the lumberyard with a 2x6 8 feet long for your sawhorses. I even hit the corners with a small roundover bit like this, so that my 2x6 has rounded corners like theirs does too. And that's just about perfect. Well, if you skip the part about making this nearly perfect 2x6 out of a couple pretty nice 2x4s, first off, I don't blame you. Second off, it's time to get started actually building these Journeyman Sawhorses. It's been a long time coming, so let's get after it. I want both ends of the top rails of these Sawhorses to have nice clean cuts, not the rough ones that come from the sawmill. And since they're exactly 8 feet long, I can't get that done because of the saw curves. So I'm going to end up making these Sawhorses 47.5 inches long, so I have nice clean cuts everywhere. So I'll make my first cut with the saw blade splitting 48 inches. And then I'll mark them again at exactly 47.5. Line up the far end perfectly and make the cut. And I'll cut the 1x6 that'll be used for the top protector cap in the same manner, so that the 2x6s and the 1x6s are all identical in length. Now that I've got the two pieces of 2x6 and the two pieces of 1x6 cut to identical length, they're nice and clean and straight like I want, it's time to set the angle of the splay on the legs to the sides. So I'm going to rip each side of the 2x6 at 12 degrees, and I'm going to leave the bottom face of the 2x6 so that it still includes its natural rounded corners, and the 12-degree bevel starts just above that, so that it maintains a full 5.5 inch width on the bottom side. Because the top side gets covered with a cap piece, I'm actually putting the good face down, because if anybody's looking, it'll show from the underside of the sawhorse. Once the 2x6s are ripped to that 12-degree bevel, I'm going to take a light pass over the joiner. You don't have to do that if you don't mind the saw marks. And then I'll rip the piece of 1x6 so that it's the same width as the angled top of the 2x6 bottom pieces, so that the cap fits nicely on the support rail. I trust the saw's angle gauge to be accurate enough for this 12 degrees, and I'm setting the width for this piece so that it still ends up 5.5 inches on the bottom after I take passes on the joiner. If you're not taking that step, just set this so that it maintains that full 5.5 inch width at the bottom. And this is what the piece looks like off the table saw. When I get back from the joiner, the smooth face will end right here at the tangent point of the small radius on the edge of the board. This whole process can be done on the job site, making these rip cuts on a job site table saw and just leaving the saw marks. The horses work just as well, but I like to spiff them up a little. With the fence set at 12 degrees, I'll make a test pass and adjust the depth of cut until the edge looks just like I want it, with a smooth face at the tangent point of that small curve. Once everything's set, I'll take one complete pass on each edge of both 2x6s. There again, this step is merely for cosmetics and doesn't affect anything else about the sawhorse. As long as I'm in table saw ripping mode, I'm going to go ahead and rip these top caps so that they fit the support rail. To do that, I've straightened one edge of these 1x6s on the joiner, but that's not necessary if you have a decently straight piece. I just put it on top of the support rail and make a mark so that the widths match. Again, I'm going to rip this on the table saw a little proud and run it over the joiner until it's the exact width I'm looking for. For the material I'm using, I'm ripping this at a strong 5 inches, and I'll plane it down to a scant 5 inches to match the top of that 2x6. Those dimensions are pretty specific and a little bit OCD, so just dial them in and cut things so that you're comfortable with the end result. And that will do nicely. Pure natural carrot juice. Breakfast of champions. Plus it makes your teeth orange. It's always a privilege to do a project like this in the shop where I've got this equipment. The first times that I built these sawhorses was usually out on a job site on a rainy day. When we couldn't get working outside, we'd spend a day in a dry area of the job site and make these on a rickety old job site table saw and a 6.5 inch skill worm drive saw. So having this equipment really makes it nice to do this work. The next step is to notch the sides of these top support rails, whatever you want to call them, so that the legs fit in flush. The sides of the rail are beveled at 12 degrees, we just did that, and the legs are splayed towards the end at 15 degrees. The notch starts 6 inches from the end, so I'll go ahead and lay that out now. If you get this distance wrong, the horses can be tippy or else they won't stack. But 6 inches with these relative angles and lengths is a workable dimension. All 8 notches on this pair of sawhorses are laid out the same way, so I'll just cover one here. Laying out the notches is pretty simple. I'm measuring along the bottom edge, not the top, putting a mark precisely at 6 inches, and using a speed square set at 15 degrees. I can get that to stay there by using my finger as a slide. I mark one edge of the notch. The width of the notches in the top rails need to match the width of the legs as accurately as possible for a cleaner and sturdier pair of sawhorses. 1x4s are generally 3.5 inches wide, and using a 1x4 to mark the notch is plenty good for a pair of Journeyman sawhorses. Again, I'm doing a couple of OCD steps here. I've taken one of the 12-foot 1x4s and rough cut it into 3-foot pieces so that I can straighten them individually and make them identical in width. Mine are going to end up at 3 3/8 inches because I'll lose an 1/8 inch in that straightening process. So I'll mark the leg notch with a 3 3/8 piece, but you just mark the leg notches for your sawhorses with whatever width your leg material ends up being. It's mostly a matter of doing these extra steps because I can, not because I really need to. Yeah, I know. Run all the legs for your sawhorses through a thickness planer? Who does that? Yep, I'm that guy. Take a piece of the material you're using for the leg, line it up on the first pencil mark, and scribe a second. By using an actual piece of the material, you're able to measure for parallel lines, because you need to measure perpendicular from one line to the other. If you measure this direction, your notch will be too narrow to fit the leg. After marking the first 2 notches, I can double down by lining up the pieces because they're precisely the same length, and then transferring the marks from one to the other, and flipping the boards and reclamping to repeat the process on the other side. And you gotta love it when that happens. This knot falls right in the middle of the notch, so I cut out that bad spot, just like I planned it. The notches in these legs need to be the same depth as the legs are thick. So I'll set a small circular saw for this 3/4 inch depth. And I can notch these 2 at a time by clamping the pieces together so that these layout lines line up perfectly and that this surface is flush. This Makita has a depth gauge setting on its guard, which I'll use as a starting point, and with my finger off the trigger, I'll just double check the depth to make sure I agree with Makita. And a setting like that will do it. I'll cut the 2 outside edges first, paying attention to my saw curve to make sure it's on the notch side of the line, because I don't want this notch to be sloppy. With the outside edges cut clean and accurate right to the pencil line, I'll make a number of cuts in between so that the notch cleans out cleanly and smoothly. Where there's a knot, I make extra cuts so that that tougher wood breaks out clean. For this straight grained wood, that's plenty of cuts for a nice clean breakout. If there's a knot going straight in, you might have to make even more cuts than that to break it out cleanly. There's a lot of ways to make this notch. Could be done with a dado blade on a table saw, could be done with a router bit. There's a lot of ways, but this is plenty clean and accurate for a sawhorse of this caliber. Here's a little spoiler. The next sawhorse video from Next Level Carpentry is going to be for the Journeyman style sawhorses, and on those I'll use a dado blade and a table saw to take the quality and the accuracy of the notch up another level. Once those saw curves are made, I can take the sharp edge of a hammer and break out all the little pieces, and then use a sharp chisel to flatten out the bottom of the notch. And with that, the leg should fit smooth and clean and flush down in the notch. I'm going to pause mid-project here and do a little cleanup. I got sawdust, shavings, and chips everywhere, and I just prefer to work with things tidied up a little bit. But the good thing is, this is one of the best kind of messes that you can get into. Nothing to it. Now it's time to cut the legs to length. Cutting these splayed legs is a pretty simple process, but it's a little tricky, so pay attention. The main point to remember is that you need left legs and right legs. So you got to make 4 lefts and 4 rights for a set of horses. Each leg has a compound angle top and bottom. The miter setting is 15 degrees because that's the splay angle for the legs this way, and the bevel setting for the saw is 12 degrees because that's the splay angle for the sides of the sawhorses. Everybody that's watching that has a compound miter box is going to be a mile ahead of me for making those compound cuts. Just set up your compound miter saw and lop them off. Because this is a Journeyman sawhorse and something that should typically be able to be built on a job site, I'm going to use that little Makita saw to cut these angles. Like I said before, I cut up the 12 footers into 4 equal pieces, 3 feet long. So I'll take each one of those pieces and put a compound angle on one end and then measure the length and cut the other end. I could use a similar process that I used in the apprentice sawhorse video, an analog way of determining the lengths of these legs, but I'm just going to take a shortcut this time and use a little newfangled technology. I built this sawhorse model in SketchUp, and the SketchUp tells me the length of the leg is 33 1/16 of an inch, so that's what I'm going to make them. I'll set this Makita saw at 12 degrees, which is right there. 3/4 inch depth setting will cut through the piece. I'll pick the clean end and the better face of one of these 1x4s and make a 15 degree mark near the end and make the cut. I went through each piece and selected the best face and the best end and put that compound angle cut on the top. I've got 4 rights and 4 lefts, and I'll now take one of these and make it a pattern with the length of 33 1/16 inch. And that 33 1/16 inch dimension is made from the long point on one end to the short point on the other. 33 1/16 inch. I'll set the same 15-degree angle cut through that point and cut this from the other face, so this ends up being the short point of the bevel. And this piece will be my pattern. This way the bevel angle is the same on both ends of the legs as well as the miter angle. Just like that. Next, I simply flush up one end of the pattern and mark each of the other legs and cut them. And here's another serendipity. This knot ends up in the scrap and not in the leg. And that, folks, is how we made compound miter cuts before there was a compound miter box. So naturally, I flip the pattern around and transfer marks to the other 4 legs. And if you're going to screw up something on a project like this, this is likely where it'll happen. So check and double check the miter angles and the bevel angles of these legs to make sure the tops and the bottoms of all 8 legs come out the way they're supposed to. And even more confusing, at this point, the legs are still the same. If you flip them around enough, the bevels and the miters are the same, but I've selected them for the top and the bottom of the leg. And when the bottom of the legs get trimmed off, that's when the left and right comes into play. Yep, that's confusing. But I know this is the short point of the cuts on these other 4 legs. And to finish up the legs, I'll put the nipped corners on the bottom ends so that the feet are less likely to splinter in use on rough ground. There's a video in the archives of Next Level Carpentry that is called Gang Cutting Blocks for Speed and Accuracy, and I'll employ the method shown in that video here and also include a link for you to see that in detail if you're interested. But basically, I'm going to square up these long points on this end so that all these long points are lined up, and then just take a piece of good 3M masking tape and cinch this bundle together. You can see there's a little bit of spring in this wood. And I'll do that with both stacks, paying attention to the left and right orientation at this point. This 3M tape is tough enough to stretch, put a little clamping pressure on, and keep everything lined up. With the legs all lined up, taped and bundled together, I can mark these ends for the bevels. And I'm just going to go with a 45-degree angle off the bottom and go up to the 5-degree mark on both sides. And that just gives a little relief from those sharp points on the bottom of the legs to keep them from splintering so badly when you drag them across rough surfaces. And remember, the 45-degree cut, the way I'm setting this up, is made off the end of the piece, not the side. And if that awkward looking cut makes you nervous, just cut them one at a time or set them up on a miter saw station with a stop block. And that's the last of the cuts necessary for making these legs. With all the cuts made on the legs, there's a couple more things that need to be done with these top rails before I can start assembly. The first thing is to screw this protector cap on top. I'll just use some of these number 25 Torx drive screws. I've got a number 8 by 1 1/4 that works great for this. I'll center up a screw on each end at 3 inches in, like that. I'm going to go 16 inches in from each end and about 1 inch in from each edge. Then I can place the top protector on top of the top rail, line up the ends and edges, and pilot hole and countersink each one of these locations with a small snappy bit. These snappy bits are great for this sort of thing, and you can find a link in the video description where I list these on the Next Level Carpentry Amazon Influencers page. When countersinking soft wood, I always leave the countersink a little bit shallow, and the screw head will pull it down flush and just a little beyond. With all the pilot holes drilled, I'll use 6 of these 1 1/4 number 8 T25 Torx drive screws to attach the cap to the top rail. Nothing to it. And please, don't bother leaving negative comments about using steel screws in the top of a pair of sawhorses. I have established the habit of not cutting into the tops of my sawhorses. The screws allow me to remove the cap if somebody else cuts through the top of my sawhorse, or if it gets damaged in some other way. If you're concerned about hitting screw heads with an expensive blade, just glue the top cap on. With these top caps screwed into place, the next thing I do is mark the ends to nip off the sharp corners. And I can get a consistent dimension by lining up the 7-degree mark with the end of the board and drawing a line without actually measuring with any particular dimension. That amount looks right to me. Once I've got one end marked, I can line up the saw blade for that cut and then put a pencil mark down on the zero clearance throw plate to repeat the cuts on the other ends and other corners. And those few steps in that sequence give a nice profile to the end of the sawhorses. The sharp corners that splinter and catch on things are gone, and it looks like I did all of this on purpose. With the caps on and the ends trimmed, the next step is to attach the legs to this top rail. I'll be using 1 3/4 number 8 countersunk Torx drive construction screws. These are GRKs that are great screws and more than up to the task of holding the legs to the top rail. And yeah, I know, I need to talk to the folks in wardrobe. This is the 4th different t-shirt they've had me wearing during this build so far. They need to get their act together. Just like on the apprentice sawhorses, screw placement is really important to maximize holding power and minimize the chances of the wood splitting. And I like to go a 1/2 inch down and 1 inch down with the top one centered up and the bottom two 5/8 inch in from either edge. That gives nice locations for each of the screw for maximum holding power in this top rail. And if you're borderline OCD like I am, here's a quick little trick you can use for repetitive marking of holes that's accurate and fast. I'm just taking a thin piece of shoebox cardboard and I cut a strip exactly the width of the leg. And on one end of it, add the angle from the end of the leg. And then make the same marks we did on that example leg. I have a center and then 5/8 inch in from each edge. Coming down from the top, going a 1/2 inch and 1 inch. And then just simply take a sharp scratch awl and put a hole at each of those center marks, like so. So you can put your tape measure away and make accurate repetitive marks merely by repunching those holes on the top of each leg. Best thing about it, because there's left and right legs, the pattern is reversible as long as it's indexed off the same point on both legs. Just like that. And an added benefit of using this template method with a scratch awl is that it's actually easier to drill the pilot holes starting with that dimple from the scratch awl than it is from an X made with a pencil. And you can take that tip and a $10 bill into Starbucks and they'll give you a free cup of coffee. So with all these pieces cut, drilled, and prepared, it's time to attach the legs to the top rail of the sawhorse. I'll be using these 1 3/4 by number 8 GRK Torx drive screws. They're a number 25 Torx drive bit for attaching the legs to the rails. I can pre-start the top center screw and use that to attach the leg. This is so much harder to do in front of a camera. And the reason I'm just placing that center screw first is I overlooked the point about pilot hole drilling these bottom 2 screws. If the screw goes in perpendicular to the face of the wood, it'll split out on the bottom of the sawhorses. So I'm repiloting those bottom screw holes so that the center of the drill bit is parallel with the bottom of the sawhorse. Because I didn't think of that when I was originally drilling those holes, I've got to repilot these. But you have the advantage of seeing my mistake so that you can drill those pilot holes at a 12-degree angle to the face of the leg from the beginning. I I wanted to have Chip come and put these sawhorses together for us here, but it's cold enough outside. He didn't want to show up to work, so I'm going to put it into high gear and screw these other two legs on. And that's about all it takes. Second verse, same as the first. I'm going to get that other one put together to this stage. Now that these horses can stand on their own 4 feet, it's time to build the bracing for the legs that holds the tray on one of the sawhorses. Those can be made out of the 1x4s with square edges, but for these I'm going to bevel the edges. So the pieces on the ends will have edges beveled at 15 degrees, the sides will be beveled at 12. So I'll take the 12 footers and rough cut them and then bevel the edges. These sides are just less than 4 feet, the ends are less than 16 inches. So I'll rough cut pieces to that length and then rip the edges to their corresponding angles. So to get the 2 4-foot pieces for the sides, essentially I just cut the long pieces into 3 4-footers. And then I can cut the 4-footers in half. And because it's nice wood, but it's got quite a hook in it, I'm going to cut one of the 4-footers in half to make 2 of the end pieces. And I'll be able to keep them wider because I'm starting off with shorter pieces. That makes sense if you think about it. And this is another juncture where you can just proceed and cut the angles on the end of these and screw them to the sawhorses. I'm going to take extra steps here to straighten these pieces and then bevel the edges. So if you're not interested in the details of that, just jump ahead to where it comes to measure these pieces and mark them to screw them on. Because I'm going to straighten these on a joiner, the first step is to bevel one edge of the long pieces at 12 degrees and the short pieces at 15 degrees. And because I'm using a joiner, it'll straighten them at the same time. And I just use a scrap of 2x4 that was cut on the miter box so that I have an accurate 15 degree and an accurate 12 degree angle for setting the fence. I'll start off with the 15 degree. Then I'll take a pass or two on each of the short pieces to straighten them and get a nice clean bevel on one edge. Looking here, I can see that it'll take about a 1/4 inch pass to put that clean bevel on there. Then I switch the bevel to 12 degrees and do one edge of each of the long pieces. And some of this 1x4 has a pretty decent bow or hook in there, and by planing this straight, it does some subtle things with the width of the board. Because these are just Journeyman sawhorses, I'm leaving it, but when it comes to doing the Master Carpenter sawhorses, I'll make sure that these pieces are flat as well as straight before they go into the project. The next step is to make corresponding 12 and 15 degree angle rip cuts on these pieces so that they're parallel and the end is actually a parallelogram. I'll start with the 15 degree pieces because they'll help determine the ultimate width of the 12 degree pieces. I'll set the angle of the table saw blade to match the 12 or 15 degrees, and because I'll be running these over the joiner again to remove saw marks, I'll leave these just a fuzz wide and clean them up on the joiner. Again, the saw marks are a bit semantic, so if they don't bother you, just leave them and rip these pieces accordingly. Notice the push stick I'm using has a couple of words of wisdom. Do not use remaining fingers as push sticks and keep between fingers and blade. These are my favorite professional push sticks, and if you think you'd like to try out this style, there's a link to a video where I show the pattern making process that I use for making these push sticks. And there was some wavering on these pieces because they have a bow this way and they feed a little bit funny through the table saw. If this was a piece of furniture, that wouldn't do, but for Journeyman sawhorses, it's plenty good. And now it's back to the joiner for those final passes for cleaning up saw marks. because these pieces get 15-degree angles on them and these get 12, I want to match up the widths accordingly after they've been ripped. And in this case, the 15-degree pieces are just a scant 1/16 of an inch wider than the 12-degree pieces. So I'll take another light pass on the joiner to even them up. And these widths vary because of the amount of bow that I had to straighten out of the different pieces and the amount of width that is taken off when the angle's put on there. It's kind of a particular little point, but sometimes this difference can be more than 1/8 of an inch and it looks sloppy. Each build is a little bit different depending on the wood used for these pieces and how much work it takes to straighten them out and clean them up. So one light pass on a joiner cleans it up. When it takes a little effort to make something a lot better, it's worth it. When it takes a lot of effort to make something just a little better, it's probably not worth it. But in this case, it went from good to perfect for very little trouble. Well, if this was a video about math for carpenters, I'd approach this next step a lot differently. You could use mathematics to figure out the length of these side pieces and the end pieces, but because it's a sawhorse build video, I'm just going to rely on SketchUp for those two measurements. And SketchUp tells me that the long point to long point measurement for these pieces with sawhorses that are 47.5 inches long is 45.25. As a side note, if you're able to make the top rails a full 48 inches long, then these side pieces would be 45.75 inches. The measurement for the end pieces from long point to long point is 14 9/16 inches. So that's the length I'll start with and adjust accordingly if necessary. Well, the nature of wood being what it is, I usually end up with an A horse and a B horse. So I've selected the pieces from the cleaner, nicer 1x4 to go with the cleaner top and the cleaner legs. This will be the A horse, and I'll put the tray on this one, and we'll use the other pieces in similar fashion on the other horse. And the simplest way I've found to approach this next step, where these rails get screwed on with the bottoms exactly 12 inches up, is to take a couple of scrap pieces of material, ripped to exactly 12 inches in height, and place them there to rest the rails on top. And I should show more confidence in SketchUp at this point, but I want to double check the length of 45.25 for these pieces. So I can just put a pencil mark on the bottom of these side braces and mark the back side of the piece. This would be much easier if I had a cameraman. All right, SketchUp says 45.25. Actual Sawhorse says 45 3/16. I'm going with SketchUp. Confusing though it may be, the ends of the 12-degree pieces get cut at 15 degrees and the ends of the 15-degree pieces get cut at 12. This is a 12-degree piece and I'm going to cut the good end off at 15 degrees and then remark the 45.25 and cut that at 15 degrees also. And make this piece my pattern for the other three. I'll make sure that these pieces are all perfectly flush on the 15-degree end and that they're square with the tabletop before making the length mark from the pattern. With those two parameters met, I can gang cut these three braces to give me 4 identical side pieces for the sawhorses. And screw placement for attaching these side braces to the legs is equally important to all the other connections, so I'll lay them out accordingly. I'll slip the side brace to the inside of the sawhorse leg and put a light pencil mark here. And with similar reasoning, lay out the 3 screws that'll hold the side brace to the leg. I'm going to go 1 inch in from the end and 3/4 of an inch in from the other end and center up this screw here and put these others at 3/4 of an inch. I'll switch to 1.25 Torx drive screws for this connection so that the screws don't come out on the inside of the leg. I should probably mention that it's important to make sure that you're assembling your sawhorses on a perfectly flat surface. If the surface is twisted, your sawhorses will come out twisted and can rock. Also, if the top beam of the sawhorse has a twist in it, it'll affect the whole sawhorse and you'll have an unstable pony when it's all done. And with this screw holes marked, I can screw these on, making sure that the end of this 1x4 is perfectly flush with the edge of the leg. I set these screws just past flush with the surface, but not so far that they come out the inside of the leg. Then I'll make a pattern and lay out the rest of the screws on the ends of these side pieces in the same fashion I did for the screws at the top of the legs. And while I'm marking this other side piece with the cardboard template, it dawns on me that I keep neglecting to mention why this screw placement. And the reason it's important is if I put two screws near the end, they'll be nearer to the edges and it's more likely to split the wood along the grain here. So I put the single screw out near the end where there's more strength in the wood to prevent it from splitting. I put it a little farther in for the same reason. The leverage has less effect as it's farther in here. And these two screws are far enough back that they're less likely to split the wood all the way through. And technically, they probably shouldn't line up this direction because they'll end up in the same parallel grain of the leg. So technically, I can offset one of these screws 1/4 of an inch or so they're not finding themselves in the same parallel grain on the edge of the wood. This is pine, and I'm less concerned about it, so I'm leaving them lined up for aesthetic purposes. The other reason about screw placement, if this screw was placed near the top and a force is driven down on the top of the wood, it'll tend to split that just from the force. So the screw near the center on the end is more stable and supports more weight. I hope all that makes sense. I'm sure there's a great level more detail as far as the engineering of screw placement goes, but I think this is adequate for carpentry of this type. This is easier to do when the pieces are laying flat, but it can be done this way too. And like before, those little dimples make it real easy to line up the drill bit. So I can countersink these holes in situ, as doctors prefer to say, or so I'm told. So there you go, you get the idea. I'll go ahead and get the rest of these side rails put on and we'll move to the ends. Fitting, cutting, and attaching these end pieces is much like the side ones, but I prefer to do it in this sequence, putting these on last. And here's why. I could do the math to figure out the length of these pieces. Again, I'm relying on SketchUp, and you can see in the model it shows it's 14 9/16 from the long point here to the long point here. But with this sawhorse assembled to this stage, I've actually got 15 1/8. So this is going to take a bit of a push to bring this to 14 9/16. The legs can be bowed, the angles at the top can be off a little bit, all sorts of things can change that measurement. But for a true 12-degree angle on each of the legs, these need to be pulled in until they're 14 9/16. I double-checked the other end, and it was about the same thing. For comparison, this horse right out of the gate is 14 5/8. It doesn't take much pressure at all to bring that into 14 9/16. The natural tendency of these legs is to spread, so the fact that I have to pull them together to fit this piece makes me more comfortable than if I had to pry them apart. But I'm going through all this dialogue to show that you don't want to just measure these pieces and stick them on wherever they happen to be once you're at this stage of the game. Determine what that measurement should be, needs to be, and why, and dial it into that, because the math is more accurate than the assembly at this stage. And these pieces are short and easy to manage, so I'll just gang cut them. But I've picked the best face and the best end of each of these pieces so that I can trim it close, make the measurement, and cut the other end. It's important to make sure that these pieces are square to the world when taping them together. And because of the angled edges, they keep wanting to slide out of position. But I know if I persist, I'll win. There it is. Pay attention to which way I'm cutting these. And 14 9/16. Long point across the bottom of the pieces. Gives me all 4 pieces in one fell swoop. And these 4 pieces are the most extravagant waste from those 4 12-footers. And I made the third and final screw placement pattern in the same fashion as before, with these screws being placed 7/16 of an inch in from the end and 1 1/8 inch in from the end. This one's in the center, and these are 3/4 of an inch in from each edge of the end piece. And again, this is the same reasoning and thought process as the other screw placements to maximize strength and minimize the potential for splitting. I'll switch back to 1 3/4 Torx drive screws for attaching these ends because I don't have to worry about the screw coming out the back side of anything. And this is one of the reasons I really like these snappy pilot and countersink bits, because it's so easy to adjust them when switching between fasteners of different lengths. It takes a good size hex key so this set screw doesn't strip out, and it's easy to set the pilot hole depth to match the screw length. I'll put a link to these snappy countersink and pilot hole bits on the Next Level Carpentry Influencers page on Amazon so that you can get a set if you need them and can't find them locally. See what I mean about wardrobe being off their game? Now they got me in a SketchUp shirt. I don't know. Anyways, once the screw locations are marked, attaching these braces to the ends is easy peasy. Since I've got the other end of the Sawhorse braced or propped, all I need to do is line this piece up on the end here and pilot hole for one of these Torx screws, drive it home. And home is with the head just slightly past flush on the board. And you can see the discrepancy here between the plan length and the actual position at this point. I'll just use a clamp to bring these two together, and that'll set the angle correctly on the legs, and the screws will easily hold it in place. And as long as both end pieces are identical in length, the Sawhorse will stay sitting flat on the floor with no rock in it, providing the floor is flat. Hard to imagine it being easier than that. Again, in this soft pine, I leave the countersink just a little bit shallow so that the screws pull snug and tight as the head draws flush with the surface. And if you look closely right here, there's a small gap. That's because these end angle cuts need to be compound angles, and I just cut them as basic angles. When it comes to the Master Carpenter Sawhorse, I'll take measures to eliminate that small gap by making compound cuts on the braces for those horses. Then it's just a matter of flipping the horse end for end and piloting and attaching the brace on the other end. If you do this assembly without piloting hole, you're bound to get cracks in the end of these pieces, especially if your wood is drier or more brittle. And I'll point out that the reason I bevel these edges is to make a nice flat surface top and bottom. I'll often put a plank through here or store lumber underneath, and having a whole flat edge instead of just a corner for it to rest on keeps the horses from getting chipped up more. And having a parallel flat bottom surface, here this is parallel to the floor, allows the tray plywood to screw on there with a nice tight clean fit. Again, neither one of those is necessary for the function of the Sawhorse. It just makes it a little cleaner and better and more professional job when it's done. And because a carpenter's Sawhorse is in a lot of ways a marketing tool, the better it is, the better it is. Once I've got the end braces screwed onto the other Sawhorse, I'll move to making the plywood gusset that ties the tops of these legs together, supports the top a little bit, and helps them stack nicely without getting wedged together. I had a half a sheet of that 1/2 inch plywood that I was going to make the gussets out of, but I found a smaller scrap that will work fine for the gussets on this Sawhorse. And because the legs are angled 15 degrees this direction to the top, I'll just rip a 15-degree angle on top and bottom of a strip that's 6 inches wide, and then mark, cut, drill, and attach those gussets. With the saw set at a 15-degree angle, I'll adjust the fence and rip the best edge of this plywood at that 15 degrees. I want to end up with a full 6 inches of width on that face. So this needs to be the short point on this edge because it's the long point on that edge. And it takes a setting of about 6 3/16 to get it. Now I've got a 6-inch wide piece that fits up underneath the Sawhorse here. And I could get this length off a SketchUp, but with the difference between a perfectly accurate SketchUp drawing and the realities and slight variations in the wood, a scribe length measurement is going to be less problematic than taking a dimension from a drawing and cutting it exactly to that, because the drawing doesn't take into account all the variations in the wood. So I'll start off by cutting a 12-degree bevel on one side. Now I'll just flush up that cut on one side of the horse and mark the other. And the scribe angle and the cut angle are a little bit different. So I'm going to cut it at 12 degrees to this short point here, and it'll be a little bit long. Then I'll make an adjustment on the actual sawhorse. As expected, there's a slight bit of extra length on this end of this horse. On the other end of the same horse, I've got the same variation. So I'm going to trim one edge of this at 11 degrees for this sawhorse. And actually, it was just a half a degree adjustment to make that work. And you can expect that much of variation and a little bit more in a sawhorse build like this, just because of the nature of the lumber itself. And I get an excellent fit on this end also. So I'll use this for a pattern and cut 2 of these for this sawhorse. And I don't need a template for screw placement here. I'll just mark in 3/8 of an inch from each edge to get to the center of those 3/4 inch legs. And let's go about 7/8 of an inch down and 7/8 of an inch up for the 4 screws on each end gusset. And because of the location of those screws, I can't get a nice pilot hole drilled like this. So for the pilot hole bit, I'll add this Irwin 6-inch ball T-tent retaining extender, and I'll switch to just a regular 6-inch ball T-tent extension for the Torx drive bit. And I'm just going to move these top screws down another 1/4 of an inch to get a clean line of attack. And that's all it takes. I spent about 10 minutes getting this sawhorse caught up to the other one so that it's all complete with the exception of no tray. For the record, these gussets measure 7 15/16 inches from long point to long point across the bottom. There's a slight variation, plus or minus that 7 15/16, but considering they're sawhorses, that's plenty accurate. And with both horses complete to this stage, they stack nicely and make a perfect pair. The last step is to cut and fit a tray for the A horse, and we'll do that next. And I could get a measurement for this tray from SketchUp also, but I'm just going to go analog and click readers and measure this at 46 13/16 by 14 3/8. And that's ever so slightly smaller than the sharp long points of these corners. So I'll make this 14 3/8 wide first. I'm going to cut it at 14 3/4 and then clean up the edge at 14 3/8. If you've got a cross-cut sled, now's the time to use it. I'm going to use my Osborne EB3 miter fence to clean up the ends of this piece. Double checking to make sure I got a nice square cut. I can live with that. And I'll go 46 13/16. If you're out on the job site, it's perfectly acceptable to make these cuts with a small circular saw. Obviously, the piece needs to be notched to fit around the legs. So I'm going to make a notch that's 4 5/16 by 1 9/16 at each corner. So I'll lay that out at 1 9/16 by 4 5/16. And experience has told me that this tray fits so tight to the bottom of the sawhorse, if it's outside when it rains, it'll just fill up with water before it slowly drains out. So to keep that from happening and spoiling the bottom plywood, I drill a relief hole in the corner of each of these notches. It helps the corner piece cut out cleanly and provides a nice, clean, purposeful relief for a drain hole on the sawhorse tray. And a sharp 1-inch spade bit drilled into a sacrificial block of wood is all that's needed to provide that nice, clean drain hole. And drilling the drain/relief hole first provides clearance for the saw blade as I cut the rest of the notch out with a small circular saw. And it goes without saying that I'm making these cuts with the saw kerf on the scrap side of the line. And a quick touch-up on all the edges with an 80 grit belt on one of the best blocks for demanding sanding cleans up splinters and sharp corners all the way around. Simple as that. I've selected this for the top face of the plywood. You can drop the tray in place on the bottom of the braces and carefully center it up between the legs and the rails. Because of the angle of these side pieces, I'll put the screws farther in than normal at about 3/4 of an inch so they can be driven straight in and not split out the face. But I'll go back to the workbench to lay out the holes. This isn't rocket surgery, but I do like a nice clean layout. So I'll sketch in that 3/4 inch line all the way around and make up some numbers that seem to make sense for the screw layout. I'm going to go 2 inches in from each corner, both directions, and divide this by 4, which will be 8.5 inches. 8.5, 17, 8.5, 8.5, 17, 8.5. And that should be a nice even layout for attaching the tray. And I've switched to the 3/32 size snappy pilot hole countersink bit because I'm using these number 7 by 3/4 inch Phillips countersunk screws for attaching the tray. And I countersink them a little on the deep side so that the Phillips screws don't stick above the surface of the plywood. The reason I center and screw the ends on first, getting the plywood correct in this direction and this direction on the ends, is because these side braces are bowed in a little bit. So with the plywood firmly attached in place, I can pull the side rail out until they're both parallel before I fasten them permanently with those screws. There's any number of ways of doing this, but I like to just reverse one of these clamps so that it's a spreader instead of a temper, and I can easily adjust the distance between those rails before I add the screws. And the same clamp pressure applied evened up both edges at the same time, meaning they were bowed in about the same amount. And once the 2 center screws are in, they'll hold the margin for those edges, which you can see here all the way along. With the screw out of here, you can see how that side rail bowed back in so the margin isn't the same. That's a lot of explanation for a simple thing, but it really does make for a nicer assembly if you take the time to work that bow out of those side rails. And the bow will just stay in the side rail on the open bottom sawhorse. Things have come a long way here at Next Level Carpentry since I first mentioned these sawhorses way last summer at the end of the Apprentice Sawhorse build video, where subscriber count has nearly doubled, I believe. So I'm really excited about what that means for Next Level Carpentry and what it has to offer for you, the viewer, going forward. It was sure nice of Chip to show up here at the end. I'm going to get after this, all right? To finish drilling the countersink pilot holes for all those screws and installing them to secure the tray to the bottom of that sawhorse. Nothing to it, right, Chip? So while he's finishing that up, I'll just ask you to smash that thumbs up button if you liked this video. It's been a long time coming. I'm glad to get it wrapped up here. And I'll ask you to consider subscribing to Next Level Carpentry if you haven't already. I'll be doing another video on these sawhorses in a little while where I add some finishing touches with a router. Then I'll actually disassemble the sawhorses completely, sand everything, and give them a nice coat of a water-based spar urethane varnish that'll help preserve them when they're out in the elements. Sometime after I do the video where these sawhorses get spiffed up and varnished, I'm going to move on to another video which a few of you know about already from replies to comments. And that video will be for what I call the Master Carpenter designed sawhorse. Quite a few years ago, I did a search on YouTube for the world's classiest sawhorse, the best sawhorse, designer sawhorse, and I found nothing. So I worked up a design and built a pair of these Master Carpenter sawhorses. These sawhorses are unique to myself and Next Level Carpentry. They've been around long enough, they're starting to get beat up around the edges. So I'm in the mood for making a new pair, and I'll do a complete build video for making those. They use premium grade materials, furniture grade joinery, and a hand brushed varnish finish that makes them stand out and above every other sawhorse I've ever seen, in my humble opinion. I can pretty much guarantee that'll be something you've never seen anywhere else. So please, stay tuned. In the meantime, it looks like Chip's got that wrapped up and looking good. So from both of us to all of you, until next time, thanks for watching.